Yeah, good morning, everyone, and welcome back to class. So before us here, we are treating a unique topic called CNC Programming. So we're going to be learning how to program our machine to be able to perform an operation using our G code and our M code. So what is G code and what is M code? M code simply means miscellaneous codes. They are code that we input into our machine to be able to run sets of operations and instructions. So here on the board, we have series of informations that we're going to check what are their meanings and how it can be applied during this programming operation. So first off is a percentage symbol that represents remark. This is how we start our programming. You have to give a definition of what you are doing. You talk the title of the program. That's where this your remark takes place. We'll see how we are going to apply all of this. The next one is your N. Is the sequence of operation. We can have N5. You can take the digits of 5 upward. You can take 10 upward, whichever one you are free with. So preferably 5. You go in 5, 10, 15, 20, so infinity. So N5, that's your first operation. Your next operation N10, your next operation N15. So it's the sequence of operation you are performing on your CNC machine. So the next one is your G code. What does G symbolize? It is called preparatory code. These are the code that sets your machines in place. So your M code are miscellaneous code. There are other codes that you use to impute. Assuming you want to tell your machine to end the program. So you are controlling the machine using the N code. While the G code, you are controlling the operations in the machine. You are controlling the operations in the machine using your G code. Okay, so going forward, the next one is F. What does F symbolize? Feed rate. That is the rate we are feeding the machine. The rate at which we are either cutting, we are either drilling, or we are either milling. That's for your feed rate. It takes the symbol F. While X, spindle speed, as we know, that's the speed at which the spindle is turning. Yeah, it is normally in revolutions. It can be 2,000 revolutions as the case may be. So we have our X. This is the coordinate along the S axis. Y, this is the coordinate along the Y axis. That's the vertical axis. And your Z is the coordinate in space. That's the third axis, where arrow symbolizes radius. Assuming we are having a circular interpolation, so we have to take note of the radius we're imputing. The radius we're imputing, that's for circular interpolation. Things like this. Assuming we want to fake a shape like this, there will be a radius at this end that we have to consider. The radius for this place that was chamfered, so we have to consider this as well. That's where the arrow takes its shape. So let's now check our G codes and our M codes and what it symbolizes. First, we are starting with G00. It stands for rapid positioning. You want to position, before then, let me talk about, let me just start in this order. So G00, rapid positioning. Assuming your cutting tool is somewhere here, you want to take a machining operation, so I can be able to wipe this side while I continue. Hey, take for example, this is the current place that we have. Okay, this signifies the initial place that your cutting tool is, and this signifies the very point you want to start the operation. So now G00, assuming you have already taken your G00 is to rapidly take your cutting tool from whichever position it is to a place you want it to be. Do you get? You don't have to take through the route of, it may not be moving X, Y, Z. You can just, assuming this is the point it is. So we want to follow the shortest distance at which you can be able to take this point from here to here. So we don't have to follow through the SY direction. You can just take it randomly into this place. It's called rapid positioning. So the next one is linear interpolation. Linear interpolation is working across the axis, either X or Y, linearly, such that you will just be moving across it linearly. Assuming you want to take an operation like this, you want to have this place milled. So you just be moving linearly, without raising your cutting tool upward. You are moving linearly without interruption. That's what G01 is for. While your G02 is called circular interpolation. Assuming we have a chamfered surface like this. You can see the surface is chamfered. So you want to move from this point. Assuming you have milled up to this point, and you now want to move to this point. So this particular point that has a radius of a certain number, let's say arrow is equals to 4 millimeters, as the case may be. We use circular interpolation for cases like this. We use it to move from the very point where the stuff stops from being a straight line to the other point where it starts from being a straight line. The curve that joins both ends is what we use linear interpolation. we use circular interpolation for. So for circular interpolation, it can be interpolated in two directions, either clockwise or anti-clockwise. Take note of the symbol I impute here. This is for clockwise interpolation. We use G02 for clockwise, while G03 for anti-clockwise interpolation. So going forward, G20. G20 is for inches input. Assuming what they ask you to work on is in inches, is graduated in inches, you know we are working with our G20. But most often they'll be giving it stuff working in meter, millimeter, centimeter. All those stuffs are called metric units. So we use G21 for them. So going forward, G90. What is G90? You know we have two different types of programming. We have the absolute programming and we have the incremental programming. So for absolute programming, we use absolute programming are programming that you always reference back to the origin. Whenever you are taking your dimension or you are checking for the coordinates of the very position where the thing is, you have your coordinates must always be referenced back to the origin. That's for absolute. Why incremental, you have to start from the very last place you stop. It's very simple. It gets me right. Assuming we are at this, let me give this stuff okay, this place is 5 and this place is 5. And year to year is 6, and year to year, this place is 2, and year is 8. This place is 4, while year to year is 2. So I want to explain what incremental programming and absolute programming means. If we want to locate this very point, following the coordinates given here, this is our reference, this is our origin, this is where the stuff starts from. Do you get? So if you want to locate this particular point, taking from the S as is, this will give you, okay, under absolute programming, let me call this point A and point B. Programming, point A is symbolizes, to get this particular point A, this is X. Towards the X axis is 6. Towards the Y axis is 2. So we call it 6, 2. That's on the XY axis. So the next one, point B, locating point B using absolute programming. You know, I'm referencing back to the origin. So B will be what? B will be taking its shape from this one coming towards this side. We can get it from this other end. This is 2 and the total length is 5. So that will be 3 from the origin. 3 from the origin, that's towards the X side, while the Y side is 4. So it will be 3, 4. This one is 4. Okay, that is, we moved, okay? This is it. We moved from this particular point to this particular point. Initially, we were on A. So we have done our operation. Assuming we did a drilling operation on this point. And after we are done drilling on point A, we now move to point B. In absolute programming, you have to take your reference back from this origin to be able to get the coordinate of this place. But for incremental, it's different. So incremental now, assuming we are working with incremental programming, incremental, our point A, this is our origin, right? This is our origin. So point A will likely be the same. It's still towards this side 6 and towards this side 2. So we have come from this origin to point A. So point A still remains our 6, 2. But point B, when we are now moving from this point A to point B, we are going to follow increments. We are taking this place as our new origin. We are no longer using this place as our origin to define the coordinates of point B. So taking the coordinates of point B, that will give us what? You will now take your dimension initially from this point. So take this point as your new 0, 0. So from this point towards this end, will be giving us what? You know, initially, this place is, oh, I'm sorry. Okay, don't be annoyed with the coordinates and with the points I use. I use 6 because the total length of this place is 5. So I know I'm off order in that point, but that's notwithstanding. Just get the information I'm passing across. So for B, for this particular point B now, let me change this place back to 2. Let me change it back to 2. So since here is 2, automatically this place 2 will be 2, 2, 2. So this place 2 will be 2. I'm sorry. 2, 2. So we want to get point B from this. So you are taking this place as your new origin. So from here to this point will be what? Taking here as our new origin. This will be from here going towards the x-axis. It will be 1. It's just moving 1 towards the x-axis. And towards the y-axis, it is moving from here to here. And the total length is 4. So it's moving 2. From this place to this place is moving 2. So it will take the shape 1, 2. You can see that's the difference between our incremental programming and absolute programming. You can see For incremental programming, your previous position is taken as your origin. If it's moving from one point to another, the last position is taken as your origin. While for absolute programming, you take your main origin as your origin, where you started your operation from initially. So going forward, that's for G90. While G91 is incremental, G92 is to reset. We want to reset, assuming the operation, this is where the initial cutting tool is now, and this is where we want to perform the operation. This is where the starting point to perform the operation is. So for incremental for G92 means you want to reset your tool from this place to this particular place. So you have to take note of the dimension. But please note, when you are resetting your tool from a particular position to another, always imagine it like though. Normally, it's your tool that will come and meet your workpiece, but imagine it like this: your workpiece that is going to meet your tool if you want to get the particular axis, because most times if the thing is at the upper end like this, your S is going to take the negative shape while your Y is going to take the positive shape. But assuming you want to take it like it's your tool coming to meet this guy, you will get it wrong. Take it like though is this guy going to meet your tool, but originally is your tool coming to meet this guy. If you want to get the coordinates very right, assuming this place is 1 from here, and this place is also 1 from here. So if we want to now move this our particular tool using G92 code, that will give us G92 into G92, you say X -1, Y +1. Do you get? Moving it from here to here. S -1, you take it like though is this guy that is moving, negative, then positive. So thank you. So moving forward, we are now moving to the M code. You know, M code is miscellaneous code. M00 is to pause the program, while your M02 is to stop. You want to stop the program. While M03 is your spindle start. You start the spindle. They are in two directions, either clockwise or anti-clockwise. For anti-clockwise, we use M04. M05 is your spindle stop, while M06 is for you to change your tool. You want to change your tool. Assuming you are performing two different operations that they gave you two different tools for. So when you are done performing one, you have to change your tool to the other to perform the next operation. You use M06 to change that. M08 is for coolant on, M09 coolant off. We really did not use all this coolant on and coolant off, but it is essential you use it, especially when the speed is very high and the rate at which you are feeding your stuff is also high too. So M30 is to end the program. This is where you end the program. End program is called M30. So thank you very much for this. So I will just solve an example to explain the fact. I think the example I'm going to solve, for those who will pay attention, it may likely become the exam question that you see tomorrow. Thank you. Okay, welcome back to class. Thank you very much. So now, as I said before, we're going to use a typical example to check how we can be able to program using our G and M code. So now this is a typical. Our area of concentration is the outlined blue color. That's our area of concentration. So all of that part is just to give us the proper dimensioning on how to fake our operation, our machining operation. So I was speaking before about different operations that you fake during your machining process. So from this particular point up until this point, okay, moving from this point up until this point, that's called tool resetting. Tool resetting. So we'll call it to reset. You are resetting to the preference point you want to use. So I'll be using beneath here for the code. I'll be using beneath here for the code. So you want to help me to, I want to use beneath here for the code now. So you follow through while we go. So the first thing you will do, it is called, you know, I told you the sequence that you are going to follow. You can start with your percentage sign for remark. So let's call this that we want to perform a milling and drilling operation or anything, whatever name they gave you as the operation you want to perform, you make it a title. So you just put other information. So you say using a cutting tool of this depth to drill 2 concentric cycles and 2 concentric hole, and following. Just all these are stories. This is your remark. So your first operation goes thus. Let's say we're starting with N5. Our first operation. The first thing you want to do first is to bring your cutting tool from this point to this point. So you are bringing it from this point to this point. So I told you, you imagine it like though is your material moving towards this point. So from this material, your workpiece moving towards the point, that will be what? It will be towards the x-axis by negative and towards the y-axis by positive. So that will give us our N5 is equals to G92, your x minus 1, your y 1. X minus 1, y 1. You can put your z if you want to put maybe z1. This z1 just means we're elevating the tool a bit above the surface of the work so that it will not be eating our work. It will not be cutting into the work, into the depth of. We are taking it a bit above the surface. So we are likely putting the cutting tool somewhere here. Okay, let's assume this is our cutting tool. Just imagine it like the stuff is turning towards this direction, and this is our cutting tool on top. So G1 is just a distance above it. We have moved it to this very point, to this very edge. So that's it. So moving forward. So after doing that, in the question, they will either tell you to do absolute programming or incremental programming. So you have to state that in your next operation. So that will be your N10. N10 is equals to G90. That's for absolute. In this case, we are doing absolute programming. And next will be what dimensions are you working? Are you working on a metric scale or you are working on the inches scale? For this, we are working on, for this question, they solved it using the metric scale, using the inches scale. But I want to solve it using the metric scale. So we are working with our G21. So G21 in this case, G21. So we have defined this and we have been able to state these facts well clear. So the next operation you want to do now is your N15. So we want to change the tool because we don't know the initial tool that was used before. We want to change the tool. I told you to change your tool. I said to change your tool, you use this operation M06. M06. That is to change your tool. M06. So you impute the tool name. Let's say, I told you T, letter T is for the name of the tool we want to work with. You can have any letters anyway, but I don't know, but T is specifically used. So it can be T001. So we have changed the tool to T001. So T001 is the name of the cutting tool we are working with. So the next operation we are going to be checking here, N15. Sorry, this is N20. N20. After we have done this, the next one is for us to put on the spindle. To put on the spindle, turn on the spindle, we use M03. M03. We turned on the spindle, M03. And we can have the speed at which the spindle moves. Let's say X200. That is the revolution of the spindle. Let's say X200. And after performing this operation, the next one is N25. N25. So I'll be wiping this place so that it will be going in that order. So the next operation I want to perform is N25. Having turned on the spindle, then what next are we going to do? We are going to do what is called rapid positioning. It is called G00, rapid positioning. We want to position the stuff to this very point as our origin, but we are still raising it a bit above Z. So that will be rapid positioning. We use G00. So our X is 0, our Y is 0, then our Z can be maybe 1, just a bit above it. So I want to wipe this place so that I can be able to, yeah. Okay, you saw the last operation I wrote. That was rapid positioning, G00. So we have rapidly positioned and the stuff is here. That is on this particular spot, rapid positioning. So the next step we are taking now is to perform, I told you this is our area of focus. So we want to perform the milling operation first. We want to mill this particular stuff. We want to mill it. Mill it. After we have done milling, then we'll drill this hole. After we have done, then we'll drill this other hole. Then we'll drill this slot. Then we'll drill this groove. This one is a groove. This is a hole. This is a hole. This is a slot. This is a groove. So we want to perform all these operations. So the first thing is for us to mill this groove, this square groove. We want to mill it. So you have to know the coordinates of this point. Tracing it with it will be posted. You will see the diagram so you can be able to trace it. Tracing it with your eye from inspection from this particular point to this point. Where do you think this point can be located in? This point here on the x-axis, it will be located at points from here to here is 0.25. Here to here is 0.25. So that will be 0.5, 0.15. As here to here is oh, I'm sorry, this is 0.125, not 0.25. 0.125. All these my 0.25s are 0.125. 0.125. No, I'm sorry, it's 0.2. Okay, we want to trace this particular point. So here to here is 0.25, here to here is 0.25. So this place will be 0.50. That's 0.50. So, but this is not the point. Our cutting, the cutting tool has a particular, this is the cutting tool. The cutting tool has a particular diameter. So what we are looking at is whatever position we are taking this our cutting tool, we are referencing it as the middle of this cutting tool, the middle. And the diameter given for this cutting tool is around 0.25. That's the diameter given. So the radius of this cutting tool from this end to this end is 0.125. The same thing with this side. The same thing with the upper side. The same thing with this other side. The radius is 0.125. Do you get? So now, if this cutting tool is brought to this particular position, if it is brought to this particular position like this, yeah. So this center, this place where the cutting tool is, this particular center that the cutting tool is now, it will be 0.125 away from the edge of the groove. Please take note of that so that you understand it. It will be 0.125 away from the edge of the groove. So automatically, this our point where the cutting tool will be, this place is 0.50. When we located it, that's 0.25, 0.25. Yes, 0.50. So the center of this cutting tool will now be 0.375. That's 0.50, 0.50, 0.50 minus 0.125. And that will give you 0.375. So we are starting our operation on the S axis on 0.375. The same thing with the Y. This is 0.25, this is 0.25. So, but the center will be at 0.375. So our first operation is starting both at, so we are doing G. You can write your G00. You can write your, G00 is for rapid positioning. Now we want to work on G01. But that your G01 is when you want to perform the drilling. You want to perform the operation. G01 is for, it's not necessarily drilling, it can be milling, it can be anything. You want to perform the operation linearly. That's when you use your G01. You can choose to write your coordinate first before you perform the operation, because you are still, you have already do your G00 to rapidly position the stuff. So you can put the coordinate first, or you can impute everything together. Either way is correct. So the coordinate first, this is N. I think my last operation I stopped was N20. If I'm right, I think N20. So this is N25. N25 will now be our X is going towards the side. That's positive, right? It's positive 0.375. While our Y is coming downward. That's negative 0.375. 0.375. Our Z can be taken a bit above it. We have not started the operation. When we start the operation, it means we have to take our Z to the depth of the cut that we want to have. For this particular milling operation, this place is our side view, while this is our top view, or you can call this your front view, whichever one. So for this milling operation, this particular operation, if you trace it downward, you see that it is somewhere here, and the depth of the milling we want to have is 0.125. Do you get? The depth of the milling is 0.125. So we want to perform the operation now. We use G01 to perform the operation that we want to do, G01. So this will be N30. N30 is equals to G01. That's for linear interpolation. We want to start working now. G01, and our X is at this particular position that it is. X 0.375, Y negative 0.375. While our Z, we are following the depth of cut, that's 0.125. This for our Z. Then you cannot put the feed rate. Let's say the feed rate is 10. You put F10. This is the feed rate that we want to start working with. So you have already imputed, this your cutting tool has already entered into it like this now, by that depth. It has entered into it by that depth. Let's say somewhere like this. Somewhere like this, around here. Let me use the blue. Your cutting tool has entered into it like this. You want to start operating, but this is not here. Your cutting tool is here. It has moved to this particular point. This particular point. You want to start working now. You want to start working. So now your cutting tool has already entered. It's already rolling, performing its operation inside. So we now want to move from this point to this point. So your y will be changing. Sorry, your y will remain the same while your s is changing. So going to the next, we are performing a linear. Since we already put G01, so the next operation you can be repeating your G01, or you can leave it like that until you want to take the next. You want to change the sequence of the code. So this one now will be our next operation here will be is moving for N35. That will be our x. Our x will change, but our y will remain the same. So our x will be, if it's coming towards this side, if you trace it down, still working with that stuff I showed you, that you have to consider the 1.125. So when you take it here, this place ought to be 1.5. But when you include when you take it from here to this point, because this place is 1, here is 0.25, here is 0.25. And so this full place is 0.1. This full place now, as it is here, it is 1.5. 1.5. So, but your cutting tool will be here. So when you move it down to this place, it will be here. It will be here. So the center of it now, the center of it will be on 0.125 plus that 1.5 will give you 1.625. So when you plus this, it's 1.5 plus 0.125, and that will give you 1.625. Do you get? So this will now give us on this part. Our x will be 1.625, while our y remain the same, 3.75. That's 0.75. And our z is still in the same depth. You can still put, we are performing the operation still inside. We have not, our z still remains. You can bring it down if you want to. So it now move to this end again. It moves to this side. This is the new point. The stuff now is like. So this point now, our x remain the same, but our y is changing. But the y is changing by, this is 0.25, this 0.25, and this is 1. So the total is 1.5. And the thing is 0.125 away from it. That will still give you negative 1.625. So that is our N40 operation. N40 operation is x is not changing, 1.625, while our y is negative 1.625. You can see we put you can leave, since the depth has already been, no need to be putting all these z. We already know the stuff is inside and is linear interpolating inside, so you may not be repeating your z. So this is now. So the next one, we are moving to this point. When you move to this point, your x will change, but your y remain the same. That's our N45. So your x will change. Your x is changing back to 3 point. That's your x is changing back to 0.375. X 0.375. While your y remains the same, 1.625. So the next operation is your N50. Your N50 is going back to the very place where you started from. That will be your x will be around 0.375, and your y also on 0.375, but negative 0.375. That's for your y. So having done this, we have finished doing the milling. So we have to take our cutting tool above it a bit. So the next operation, which will be N55, that will be N55 will be equals to, we'll call it G00. We want to, immediately after you have done one operation, you take your G00 and you take your tool a bit above it. So the next operation will be N55. I told you do your G00, rapid positioning. This X0, Y0. Your Z is just a bit above it. We are not taking this our cutting tool. The cutting tool has done all this operation, everything. It has gone here, and come back to this place. So we will not take it. We'll take this our cutting tool to be a bit above it. That's why we are putting it to be having like 1 point something. It can be 1.00, it can be 3, it can be 5, just a bit above it. So we have done rapid positioning. We want to perform the next operation. So what is the next operation we want to perform now? Is to drill this hole. So we have to locate the coordinates of this hole. if we not take our tool to this particular position, where do you think this position will be located in? Trace it. You will see that here is 0.25, here is 0.25, and this place from here to this center of the O, it is 0.375. That's 2525 plus 0.375. That will give you what? It will give you 0.875 towards the S axis. You know, the center of the O will also be your center of the cutting tool. So your cutting tool, this food stuff here, it will be entering inside the O because they both have the same diameter. The diameter of this O, they gave us here to be 0.250, and the diameter of the cutting tool given is also 0.250. So it will just fit into it. So they will have the same coordinates. So automatically, this particular O will be having, if we want to get the coordinate of this O, that's 0.60, N60. N60 will give us on the x-axis, it will give us x 0.875. While on the y-axis, the y-axis will be this 2.5, this 0.25, and this place to the center is also 0.25. So that will give us 0.75. Y 0.75, but it will be negative. So negative y 0.75. We have not started our drilling, so our z is not considered. So now do your G01. Want to start work? G01, linear interpolation. Take the same coordinate. This is 0.875, y minus 0.75, y your z, the depth of the hole we want to drill. If you trace your hole down to the front view of this stuff, you see that the depth of the hole is 0.25. 0.25, that's the depth of the hole we want to drill. So your z is now negative 0.25. Negative 0.25. Negative 0.25, that's your z that we want to drill, the depth of the hole. So I haven't considered that we have drilled the hole already. So when you are done drilling the hole, then you do your G00. After you have done drilling the hole, the next thing you do is to take it out. You are done drilling like this. You have to, because you can't move from this point to this new point. It's not done. Therefore, you are going to scatter the work. When you move from this point to this point, it's as you doing a linear interpolation over this place. It will scatter the work. So it will not give you the shape you are looking for. So once you are done drilling, you have to take your tool out. You take it out to this point again. That will be your G00, your X0, Y0, while your Z1. Do you get? Hope you are following. With this, I know you have already understood this stuff. You can be able to finish the rest. So, but I will definitely assist you to finish it. So, the next operation we'll be doing after this is to drill this other O. You have to locate the coordinates of this other O. Locating this coordinate, following the point, you see that the coordinate is located. You can locate it from the down and subtract it from the whole number, or whichever side you want to locate it. So, from this particular point towards the X, it is towards the X. Let me locate it towards the X. So, this point is 0.25. And this point is 0.25. This point is 0.25. That's 0.25, 0.25, 0.25. That will give you what? 0.75. 0.75 minus the total one. So we want to get it from this particular place. That will be 1.25 towards the X, from this particular place towards the X. So you will now do, to locate that point, that will be your N. This is N55, N60, N65, N70, N75. This will give us your X is on 1.25. While your Y, tracing your Y downward, this is, you can trace it from the bottom too if you want to. So this side is 2.5, this side is 2.5, and this side is 3.75. So this full one is 0.875. 0.875 minus this full one, which is 2. 2 minus 0.875, that will give you 1.125. So your Y will be negative 1.125. Do you get? So now I want to perform the drilling operation. That will be your G01, linear interpolation. You repeat the same stuff, 1.25, while your Y is 1.125. Then your Z, which is the depth of the hole, giving us negative 0.25. 0.25. So we have drilled this hole now. So the next operation, you take it out. You take it out. That will be your N. This is N80, and this is your N85. Your N85, you take it out. That's your G00, your X0, your Y0, then your Z1. You can see it's very simple. So we have successfully milled. We have drilled this hole. We have drilled this hole. So we want to do this slot. To drill this slot, we have to start from this point. You know, they gave us some reference point. They gave us A, give us B. I think this place is C. So we want to start from this C, then we'll do it up until this point. This is where circular interpolation comes in. So we have to first of all locate this point, locate this particular point. But after we have located it, then we drill using this the depth of this our slot is the same depth that it has with this other guy. It's not the same depth to the hole. It has the depth of 0.125. So after we have drilled, then we now circular interpolate. We move. No, not even this. We're not circular interpolating for this one. I'm sorry. We're not circular. This one is still linear interpolation, but we will not take it out like the way we have been taking it out from this one to do this one. But still on this point, after we have done drilling, we have to locate this next point, the center of this place. The center of this place. So we now circular, we now linear interpolate it to this new position. It's as simple as that. So we do the same for this guy, but this guy we are not linear interpolating. We are going to circular interpolate using the radius given. So let's work. Let's go. So now working on this, trace this your point B. When you trace this your point B, you see that your point B is currently at, on your S side, this 0.25, 0.25, and this place is okay. Let's trace it and see. Let's trace it and see. So this 1 on your is 1 because this full place is 1. So when you divide it into 2, I think it's at the exact half. When you divide it into 2, it will give you 0.5. But you can still get it the other way. Okay. This is, you can get it this way. So this is 0.375, right? 0.375 plus 0.25, 0.25. Yeah, that's how you should get it. True. So 0.375 plus 0.25, 0.25, that is 0.875. So practice from the very beginning. You'll be getting one on the x-axis. You'll be getting locating your. The last operation was G00. Locating your x-axis. Let's say this is our N90. Locating your x-axis. Your x-axis will be 1.125, while your y-axis will be negative of. So this place is 0.25. This place is 0.25. And I think this particular position here is this 0.3 on the x side. Okay. On the y side, this 0.375 to this center. So while on the x side, this 0.25 and this 0.25. 0.25, 0.25 and 0.375. That will give you 0.875. So that will be y will be negative of 0.875. 875. So we have gotten that position of y. So the next thing for us to do is to locate, after we have located that point, this point here is now for us to drill, perform the operation. That will be our G01. So repeat that same point, 1.125, y 0.875, then the depth of the hole, which is 0.25, 0.125, yeah. 0.125, that's the depth of your negative 0.125, the depth of your. So you are successfully drilled. So you now want to move from this point to this point without taking it out. You want to move inside the workpiece without taking your cutting tool out. So locate this other point, this point here that I put cross here. Locate the point. So this point now will be, if you want to locate it, I think it has the same center with the center of this hole, which is 0.25 here. So 0.25, 0.25, that is 0.75 minus the full length, which is 2. So it will be 0.125 towards the S side. And while the y will be locating the y. I think the y has the same depth with this guy. So the y is 0.25 here, 0.25 here, 0.25. That's 0.125 minus, that will give us 0.75. So let me write so that you will not look confused. So we're not taking it out. We are still in the same place. So this is our N100. This is our N05. So still on G01. You may want to write your G01 or just leave it like that without taking it out. That will be on your S axis. That's point. Okay. On your X axis, that's point. Okay, 0.125, while on your y axis that's negative 0.75. Yeah, hope I'm still in line. Confirm I'm still in line. Yeah, I think I'm correct. So moving forward, the next operation is our N110. So we have finished interpolating this guy. So you cannot take it up. G00, your Z, your S0, Y0, then your Z1. So we have taken it up. After then, the next thing that you are going to do now is to do this, our groove that we have here. So now it's for you to locate this your point C first. It's the same operation that you perform here that you also perform here. But this place, instead of it, this place you linear interpolated because it was this, it can move linearly. But this other place, it cannot move linearly, it's a curve. So you have to do circular interpolation. That's just the difference. So locate this point C first. Locating the point C, that will be the point of C is on X. Okay, let's check together. Point C. I think point C is having the same, they're having the same center together. So point C will be on this 25, 25, 25. I think 0.75. So 0.75 on the x-axis, while on the y-axis, this is the total length for here is on the y-axis for this guy. I think this guy is here is 0.50. If here is 0.50, this place will be 0.502. 0.502525. So that's 1. So on the y-axis it is negative 1.00. So now I want to start the work. So do your G01. So this place is N115 and this place is N120. So do your G01. So this repeat the same point, 0.75. Your y is 1.0, while your z is the depth of the hole, which is equals to negative 0.125. So I haven't done that. I want to clean and continue the operation at the top. So the next operation is N125. So I've successfully drilled this place. So I now want to move it from this place to this place. This place where I have my black marker. So this place. So I have to locate the point of this place. Locating the point of this place, this will give me, let's locate it together and see. On this part of the X, this is 0.25, 0.25. And I think these are the center. These are the center of, so this place is I think these fours are the center. So this place is 1, 25, 25, and here is 0.5. So on my X, it is, sorry, let me use a better marker. On my X, it is 1.00. So while on my Y, this 25, 25. Okay, let me trace it from the bottom. Maybe it will help. The bottom. Which one will help faster? Okay. Either ways. So tracing it from the top. So this will give me this 0.25 and this 0.25, and this place is from here to here is 0.25. Yeah, I'm quite sure of that. It's 0.25. I'm very sure of that. So this is 0.25, 0.25, 0.25. So minus it from the full stop, which is 20. So that will give you on my y, it will be negative 1.25 as a 1.250. So that's on my y. The depth still remains. You know, I've not taken it out. The depth still remains. So having done this, so I've successfully done my interpolation up to this here. So I now raise my 2. So this is my N130. My G00, I want to raise my 2, S0, Y0, there's Z1. So after I've done this, so I cannot take my stuff. I've already raised my 2, do my random rapid interpolation. I've raised my 2 to this. Is now at the 0 point. It's at the 0 point. So I now want to move it to this original place where the 2 is. So going from this place to this place where the 2 is will be the reverse direction of how I started. So I will be taking it like though it is this 2 now coming to meet me. So that will be on my, taking it back, this will be 1, N135 will be equals to, your X will be positive now, 1.00, while your Y will be negative, which is minus 1.00. I haven't done this. The next thing is to off my spindle. So this is 140. To off my spindle, that's what? I told you to off spindle is equals to what? M05. So you off your spindle. After I've off my spindle, then I cannot stop the program. So that will be my N45. To stop the program is N30. So I stop the program. With this, ladies and gentlemen, we have come to the end of this class. Thank you very much. Hopefully this becomes your exam question. God bless you.